Hi, this is Christopher Boucher, and I'm going to review how to do a hypothesis test with a t-distribution, and we're going to use the rejection zone method. Okay, to get started here, here's the problem. The average annual salary for a starting painter in the United States is $30,000. A sample of 16 new painters shows an average annual salary of $31,000 with a standard deviation of $300. Based on this data, are new painters earning significantly more than expected? So what we have is a setup for a hypothesis test. So right off the bat, we can look at a couple things here. Let's see, our null hypothesis is going to be that the painters are earning $30,000 or less because we're testing to see if the null hypothesis is true or if we should reject it. So the null is going to be mu is 30,000 or less. And what that means is our alternative hypothesis is going to be more than 30,000. And our mu is 30,000. And our S, which is our standard deviation. Now this is the standard deviation of the sample. Now you know that it's the standard deviation of the sample because of a couple things. First of all, the way it's written up front, where it talks about the population mean is 30, and then it talks about the sample, and it says the sample of 16 new painters shows an average annual salary of $31,000 with a standard deviation of 300. What that means is the standard deviation is connected to the sample mean. So our standard deviation for the sample is 300. And our mean for the sample is 31. And our n is 16. So a couple things here right off the bat. We have an unknown sigma, or population standard deviation, and we have a small sample. So n is less than 30. So we're going to use the t-distribution. It's appropriate for this. Now, I used to think that the t-distribution was a little bit more complicated than the z, but I actually kind of think it's easier with using the rejection method. It's really easy. Okay, let's draw out our hypothesis distribution picture. I always recommend doing this. Okay, now what we want to do is we want to identify the area that is our rejection zone, and our alternative hypothesis is always pointing towards the rejection zone, or area of interest, which is what I also call it. So we'll call this our rejection zone. This would be our mu. Theoretically, that's the middle, it's the mu. If we do this, lay this out as standard deviations, this would be the middle, no standard deviation, which is where the mu is. Okay, so what we want to do now is we want to find the critical value for this area right here, and then we're going to calculate our test statistic to see if we are in the rejection zone or not. So for our critical value, it's pretty easy with a t-distribution because we have our table. So our critical value is the t-distribution. So our degrees of freedom, we need our degrees of freedom. They're always n minus 1 equals our df. What that means is 16 minus 1 equals 15 for our degrees of freedom. So we have 15 for the degrees of freedom, and then we are performing our hypothesis test at a 5% level. You could write 0.05, that would be okay too. So Now we're going to take a look at our table and see what our critical value is. This table that I have works out really nicely. It's set up for one tail and two tail. Because this question is looking for more, it's just a one tail question. And we have our degrees of freedom. I'll zoom in a little bit. A little bit of glare from the lamination. Our degrees of freedom is 15. And we're looking for 5% on the one tail test. And this says one tail. It's a little hard to see, but this is one tail and 5% right there. So it's 1.753. 1.753, that's our critical value for this cutoff for the hypothesis test. 1.753. 1.753. So we could write that right here. 1.753. And these are essentially in standard deviations. Standard deviations away from the mean. It's all about the rejection zone method. So we're just looking at how far out it is based on the probability of it happening by pure chance. Okay, let's do the calculation. The calculation for the t-distribution is very similar to what you've seen before with the z. So that's same setup as the z-distribution, but we have a sample standard deviation. So let's work that out. In this one, I'm not using the calculator. I'll use the calculator and talk about the p-value method in a later video. Might run out of room right here. Which I think I will run out of room. And then it's 300 over the root of 16. So bringing this down, I have the answer calculated for ease. It's 13.33. Huge number when you look at what we're working with. 13.33. So we take this 13.33 and we see where it fits in. Now, as we move away from mu, our scores or our t-score increases. The number of standard deviations in this case away from the mean. So our score that we got off the table, 1.75, it increases as we go either to the right or to the left. So this obviously is way into the tail, which means we're going to reject H0, our null hypothesis, which means our findings are significant based on the testing parameter, and it looks like painters could be making more than the average in the United States of 30,000. Now, one test doesn't mean that it's necessarily the way that we believe it is. We could have a bad sample, we could have all kinds of problems, but we might want to look into this more and do more testing. Okay, thank you for watching.